morning, good afternoon, good evening, whenever you're watching this video. I hope you're having a good day. In this video, I want to address the question of when in terms of frequency distribution tables. Specifically, when are they used, when are they not used, and when are they, one particular question as to when are they modified. Now, the answer to the first question, when are they used, obviously is going to help us understand the second question, when are they not used. So let's address that first. When are they used? Okay, they are used when I am trying to describe a specific type of data, categorical data, namely. Sometimes it's referred to as qualitative data. Sometimes it's referred to as nominal or ordinal data. If we see one of these words, categorical, qualitative, nominal, ordinal, we see this to describe that data, then more than likely that's when I'm going to create a frequency distribution table. If, however, I start seeing words like continuous, interval, ratio, quantitative, if these are the words that I'm seeing as it relates to the data and describing that data, then I'm not likely to use a frequency distribution table. Well, why is that? Well, simple reason. Categorical data, qualitative data, ordinal, nominal. This data has clearly defined boundaries, and it's based on frequencies or counts and not some measurement. And measures typically use an instrument. So if the data that I am using, and I'm trying to create a table, and I'm going to try to decide, do I use a frequency distribution table or not? Go back and look at the data. Is the data being described using frequencies and counts? If the answer is yes, then you're going to be building a frequency distribution table. If the answer is no, then don't. Now let's talk about the tricky question of when do I modify them? Okay. Those of us that like math and love to get into mathematical arguments, I'd like you to sort of let that go for a minute. When we modify a frequency distribution table, it is usually to help us tell the story that we want to. For me personally, I like this table because it has all of this information and it's rich in its information. But the reality is, most people don't need all of this information to understand the story that's being told. And so a table that is most commonly built and modified would be this table. You notice we got rid of the missing data, and we got rid of the valid percent, and many times they'll even get rid of the cumulative percent and just have variable name, frequency, and percent. Is one of them right and one of them wrong? No, it depends on the story that you're wanting to tell. We modify accordingly. Now here gets another tricky question. What about when it doesn't add up to 100%? And here's where people really start getting into mathematical arguments that you don't need to be. Yes, you're right, this didn't add up to 99.9. And yes, it should add up to 100. Did you do something wrong? Probably not, because mathematically speaking, it is possible to run all of these computations and not get 100%. Now, if this had come out to 92%, well then yeah, something's wrong with the math. But I tell students all the time, if it comes out to 100.1 or 99.9, probably safe in assuming that it's not a mathematical error as much as it is just a computational occurrence. These things happen. Well, then what do you want to do? Do you want to leave it with the 99.9%? I would argue no, because I guarantee someone in the audience will pick on that, and that's not the point of the discussion. Okay, so how do I solve the problem? It's very simple, actually. If I take the 99.9, I make it 100. I then take the lowest value, and I add a percentage point. Now it's 100.0%. What if it said 100.1? Well, then I would take the 100.1, make it 100, and I would take a decimal point off the highest percentage value. Why? Well, because that is returning to the center of the distribution of these percent values. It's that simple. The reality is no one's going to pull out a calculator and go 17 divided by 59, 6 divided by 29, 6 divided by 29, 5 divided by 29, so on and so forth. All they're going to see is the 58.6%, the 20.7%, and they're going to start telling themselves a story, and then they're going to read what you wrote, and you're going to probably want to highlight the fact that over half of the articles in your dissertation were published in the 2010s. Especially if your dissertation was written in the 2010s, you'd want most of your research to be relevant. They're not going to get into a discussion of, well, why doesn't this add up to 100%? Because they're just going to accept the 100%. And then you would do the same thing here. By adding that percent value, now my cumulative percent comes out to 100. And we don't have to get into that discussion. I hope this video has answered some of your questions as they relate to frequency distribution tables. If it's raised some, I'd be happy to hear them. Please send them in, let me know. Otherwise, I hope you have a good day.